Hello everyone, we are in the second part of amine. In the first part, we have learned ionization of amines and fragmentation of aromatic amine, where we have studied the alpha cleavage and loss of hydrogen cyanide from the aromatic amine to give corresponding cations. In this lecture, we will discuss the fragmentation of aliphatic amines. Fragmentation of aliphatic amines. Generally, the aliphatic amines, that is primary, secondary and tertiary aliphatic amines, they undergo alpha cleavage as like aromatic amine, and after alpha cleavage they form their corresponding iminium ion in which there is a carbon double bond nitrogen. This type of structure that we have studied in the fragmentation of aromatic amine. Now we will start with primary aliphatic amine, and in this point we will discuss two examples of primary aliphatic amine which are having same molecular formula and same molar mass. First example is 1-butylamine. Then structure of 1-butylamine is like this, and here is the presence of amino group having nitrogen lone pairs. Okay, name is 1-butylamine. And the second example that we are going to discuss is this one, in which one carbon is substituted one and there is a presence of NH2 group. It is 2-butylamine. Both are primary aliphatic amines. If we carefully look the structures of both compounds, we will find that number of carbon, number of hydrogen, number of nitrogen, they are same, but there is a different arrangement of the groups. Here this carbon is substituted. That's why these both structures are called as structural isomers of each other. Now, when they undergo ionization and alpha cleavage, they forms iminium ion with different M by Z value. Though they are having same M by Z value in the molecular ion, but after alpha cleavage, they forms iminium ion with different M by Z value. Why this happen? Of ions, they are formed after alpha cleavage. In case of 1-butylamine and 2-butylamine, they differs in their M by Z value, that we are going to discuss deeply. Okay, first of all, I will carry out the ionization of both. Here we get this type of molecular ion after ionization of this compound. Nitrogen possesses positive charge and there is a single electron. The M by Z value, if you calculate, it is found to be 73. Now, when 1-butylamine undergo alpha cleavage, what will happen? In alpha cleavage, the bond which is next to nitrogen, which bond? Carbon-carbon bond. And here, this is the bond which is carbon-carbon bond and next to the nitrogen. That's why in alpha cleavage, carbon-carbon bond is going to break here, and after breaking, one electron is transferred here and one electron which is transferred to this bond, and it is going to combine with the single electron on the nitrogen, and after that we are getting this type of radical CH3, CH2, CH2 radical plus remaining will be the iminium ion, and the structure of iminium ion, it is CH2 double bond NH2. Nitrogen carries positive charge. This is the iminium ion, and the M by Z value of this iminium ion is 30. Is 30. Now, if I ionized this molecule, that is secondary butylamine, what will happen? No doubt I will obtain this type of structure in which nitrogen carry positive charge, NH2 positive and single electron. Then alpha cleavage of this molecular ion. I will write here alpha cleavage. Before alpha cleavage, I will write here M by Z value, it is 73. Here it is 2. Okay. Look at the M by Z value of 2-butylamine, it is 73. Whereas in case of 1-butylamine, it is also 73. Therefore, M by Z value of the molecular ion is same in both cases. Okay. But there is a structural difference between the molecular ion. Now, if alpha cleavage occurs in secondary butyl or 2-butylamine, if alpha cleavage occurs in 2-butylamine, then we will get in alpha cleavage this bond is going to break, as well as this bond is going to break. In 2-butylamine, there is a possibility of 2 alpha cleavages because there are 2 bonds which are next to the nitrogen. Therefore, here alpha cleavage occurs and here there is also alpha cleavage. Therefore, we will draw a iminium ion for both these alpha cleavages. I will put here 1 and here 2. So, first of all, according to the alpha 1 or breaking of this bond, we get CH3, CH2, 1 radical plus, and as this bond is going to break, then the CH double bond NH2 positive charge, and here there is a CH3. Okay, this is the first iminium ion having M by Z value. Here it is found to be 44. Okay, then if second cleavage occurs, then what will happen? This CH3 group is eliminated as a radical and remaining will be the cation, that is iminium ion. Then I will write CH3 radical plus CH3 CH2, here CH double bond NH2, and here positive charge. In this case, we will get 58 as a M by Z value of iminium ion. Now, these are the 2 alpha cleavages that occurs in case of 2-butylamine. Now, look at the structures of radicals that are formed in 2 cleavages. This is ethyl radical, this is methyl radical. And according to the fragmentation rule, the cleavage in which there is a formation of larger radical, that cleavage is favored one or preferred one. Therefore, out of alpha 1 and alpha 2, the alpha 1 cleavage is preferred one or favorable. Therefore, we generally get the iminium ion having M by Z value 44 because this cleavage is favorable in case of 2-butylamine, or it is preferred one because of the larger radical formation, and larger alkyl radicals are stable one. So in this way, though the structures of amine are having same molecular weight, or same molecular formula, the alpha cleavage which is observed in case of amine may give different iminium ions. So one butylamine, it will give the iminium ion having M by Z value 30, whereas in case of 2-butylamine we get 44 and 58, out of which the iminium ion having M by Z value 44 is stronger. So from this discussion, it is clear that if alpha substitution is absent in primary amine, listen carefully what I am saying. If alpha substitution is absent in primary amine, we get the iminium ion having M by Z value 30. Example is 1-butylamine. 1-butylamine. And if there is a presence of alpha substitution, then we get the iminium ion having value 44. If there is a CH3 substitution, then we may get 58 if there is a C2H5, and again 72, and so on. If substitution changes, then these values are also going to change. So instead of 30, we get 44, 58, 72, then 86, and so on. Therefore, the alpha cleavage depends upon the alpha substitution present in primary amine, and it can be demonstrated by using corresponding mass spectrum of 1-butylamine as well as 2-butylamine. Let's see the mass spectrum of 1-butylamine and then 2-butylamine. So this is 1-butylamine, it is 2-butylamine. Here this peak, it is peak of molecular ion. Here it is 73, this peak. Now in 1-butylamine we get iminium ion having structure this, okay, and M by Z value is 30, and this is the peak in case of 1-butylamine, which is due to the iminium cation or iminium ion. And in case of 2-butylamine we get the peaks at 44 as well as 58, out of which the peak at 44, it is prominent one, and the structure of that iminium ion is like this, CH3 double bond NH2 positive, and that's why the peak at 44, it is appear as a stronger peak. Therefore, the peak which are observed after alpha cleavages, they are base peak in mass. You should remember that the peak which are observed after alpha cleavages, these are base peak. It is base peak, it is a base peak. Though the molecular formula of the compounds and M by Z values of the molecular ion same, but there is a difference between iminium ion, M by Z values of iminium ion. Now we will turn towards fragmentation in case of secondary amine. Example of secondary amine I will take here. It is diethylamine. CH3 CH2 NH CH2 CH3. Diethylamine. If it is ionized, it will give the molecular ion CH3 CH2 NH CH2 CH3. Here positive charge, single electron, and after ionization it will show alpha cleavage. Now look at the structure, and Find out the carbon-carbon bond which is next to the nitrogen. Here it is the first carbon-carbon bond which is next to the nitrogen, and on this side this is the second carbon-carbon bond which is next to the nitrogen. Therefore, there is a possibility of two alpha cleavages. But if we carried out the alpha cleavages, as both the substituents CH3, CH2, CH2, CH3, they are same one. Therefore, in both alpha cleavages, we will get this type of fragmentation. And here is a CH3 radical plus CH2 double bond NH, then CH2, CH3. This type of iminium ion we will get in both alpha cleavages. And the M by Z value of this iminium ion is 58. In secondary amine, other than alpha cleavage, there is a possibility of loss of hydrogen radical. Let's see how it occurs. This is secondary amine. Again, I will write ionization and it will generate molecular ion CH2, CH2, then nitrogen positive single electron. Then from this molecular ion, hydrogen radical is eliminated. And which hydrogen? The hydrogen which is attached to the nitrogen. And after loss of hydrogen radical, we will obtain CH3, CH2, N, then CH2, CH3. Here, nitrogen contains positive charge. In this way, we may get a loss of hydrogen radical and corresponding ion at M by Z 72. Now, look at the mass spectrum of secondary amine. The molecular ion peak is observed at 73. Then loss of hydrogen gives peak at M by Z 72, whereas formation of iminium ion, I will write iminium ion at M by Z 58. Now, find out the peak at corresponding M by Z values. This is peak at M by Z 73, that is, it is molecular ion peak. And next to this, it is having M by Z value 72. It is due to the loss of hydrogen. And the peak which is near to the 60, that is peak at M by Z value 58, it is due to the iminium ion. In this case also, the iminium ion peak is having highest intensity, that's why it is a best peak. It is a best peak. Okay. Now, the last point in this lecture is fragmentation in case of tertiary amines. I will write tertiary amine. No doubt there is always alpha cleavage in case of tertiary amine, and we will see the example of ethyl dimethyl amine, again having molar mass 73, that is whatever the molecular ion is going to form in the tertiary amine, it is having M by Z value 73. Okay, the example that is I am writing here is CH3 N CH3, then CH2 CH3. Nitrogen contains lone pair of electron. It is ethyl dimethyl amine. Again, ionization of this compound, it will generate CH3N CH3, then CH2 CH3. Nitrogen contains positive charge and single electron. Next step, there is a alpha cleavage. It is prominent fragmentation pattern observed in case of amine. Now look at the structures and find out the carbon-carbon bond which is next to the nitrogen. On this side, the carbon-carbon bond is present here, which is next to the nitrogen. That's why in this compound, this bond is going to break. And after breaking, we will get CH3 radical and corresponding iminium ion CH3, then nitrogen CH3, here CH2 double bond, and here it is a positive charge. If you calculate the M by Z value of this iminium ion, it is found to be 58. Therefore, in case of tertiary amine, there is a alpha cleavage which will generate iminium ion having corresponding M by Z value. Now we will see the mass spectrum of tertiary amine. In the mass spectrum of ethyl dimethyl amine, the molecular ion peak is observed at M by Z value 73 and iminium ion is observed at M by Z value 58. The peak which is having M by Z value 73, this is the peak, and this peak which is having highest intensity has M by Z value 58. In this way, in this lecture, we have learned that the amines undergo alpha cleavage to give iminium ion, and the iminium ion gives a stronger peak, or the peak having high intensity. And these peaks are nothing but the best peak observed in case of all type of amines. I hope that you have understood this part, and I am going to conclude this lecture. If you have any doubts or any queries about the fragmentation of amine, you can write me. Thank you.